So can we again use somewhat icons to see what we are drawing there? And then we said, okay, we wanted to have a pen on there, so how can we do that? And all the time we have to refine our prototype in a weekly base until we come to, well, this is somehow a picture of the actual thing that I have on my laptop right now. So it looks like that. This is the outcome of a long history of this tool, and it's we presented it the very first time last week in Munich on the AES, and it is pretty promising about the success of it. So Foley artists love it already without having it.
What does it do?
What does it do? It's a good point. So you forgot our last presentation. It's about querying audio databases. You can sketch audio, so to speak. Every icon on the canvas represents a tiny, we call it atomic sound. And the sum of all the sounds is then used to query an existing audio database on the content basis.
Onomatopoeia. I had a hard time learning this word. We did some research also with the goal of finding files by other means than just typing in the text or sketching them, as we saw in the tool before. We did some research into using onomatopoeia tags. Well, now I got it wrong. Anyways, to analyze audio and create funny words from it. So something like whatever. So basically trying to map this audio file to another representation that comes close to the language that humans would use to describe these sounds. This tool analyzes the audio file and creates this little bit of text from it, makes it shorter so it's more readable. And this would be some of the metadata that we plan to store with audio files, with those more noisy files. So, on to the file system tricks.
Well, again, Michael delved deep into the file system things of different operating systems like Linux and the Mac and the Windows file systems, and he gathered a lot of hints and tricks that can be used for audio production. This is pretty ugly to explain and of course to present, because this is a lot about some weird addresses that are stored on hard drives and other kind of memory. Well, what we find out is that we found some ways how we could, if we had that idea of the whole toolbox thingy that we wanted to achieve from our vision, how to interface or access any existing editor or existing software that is on the market by simply using the file system itself.
All right. What we also developed for analyzing sound was a tool that implemented all the MPEG-7 audio descriptors. We implemented all 19 of them, and this tool would basically extract those features such as harmonicity, what else do we have? The spectrum envelope, audio spectrum, and so forth. It's basically a standard set up by the MPEG group on how to describe the content of audio files. Anyways, we have not used this in any of the applications so far. What we're using there is basically MSCC features and a lot of fancy math. So this is something that's fully functional, but it's still waiting for the right application to be incorporated into.
Okay. Another kind of instrument we come up with was the speaker drum. question was, can one use an existing loudspeaker as a drum? So you can, whatever, tip your fingers on the membrane, on the diaphragm, and maybe get some sounds of it. The answer is yes, you can. And the problem is, you cannot treat it as a drum. So as everybody can imagine that if you just use a drumstick on a diaphragm of a loudspeaker, it will break immediately. So my idea was to mount it in an existing drum as a bottom hat. And the result is that you can tweak the sound of the speaker drum, and so you can somehow tune and change the sound of the drum in real time by just tweaking some knobs. Well, yeah, we did that.
We also have a website. The address is up there, noise.hexperiment.de. It has links to some of the papers, some are still under copyright, but we can send them to you. Basically the AES papers still have to wait for some time, I guess. But you can pick up your copies here or we'll mail them to you. There's contact addresses, some stuff that we did, links to YouTube videos describing the tools, links to our personal web pages. And of course, the names of everyone who took part in the project. So yeah, feel free to visit that website.
Okay, more things that we did. Our EST Optimizer is a tool that can automatically set up VST or a cheap, let's say a cheap reverberation effect that comes as an VST plugin, that it sounds like an existing recording of a room. And we are using genetic optimization strategies here, and we thought that was just a somewhat weird idea and more on a theoretical question that does it work or not. And then we presented it last week, and we get a lot of amazing comments from some manufacturers that really like to have that tool to communicate to their customers, because this VST technology from Steinberg is well common in way more applications than one would imagine. It's not just about Cubase and all the MIDI editor stuff. It's also used for on the business-to-business market to change algorithm, exchange algorithm ideas and setups and so on and so on. Okay? Oops.
So, on to the next slide. There we go. The enhanced faders. Basically, does it work? Well, let's do it the old-fashioned way, just by clicking. This was something that we did to find out how the interaction with on-screen faders can be improved. A lot of audio applications have faders, like this one on the screen, but quite often they're quantized to pixels, they're really hard to use. Sometimes you have a mapping where you move the mouse a lot, the fader moves a little, then you get stuck at the screen boundaries, so the existing faders have a lot of problems connected to them. So what we did was we built this nice little mouse, which is fitted with a pressure sensor, which sits right here, to give you an additional degree of freedom on the mouse. And you could basically use this pressure sensor to adjust the mapping between the mouse movement and the fader. We did not only test it with this mouse, but we also had other approaches like the perpendicular zoom, where you would move the mouse left and right to adjust the zoom value. Simply clicking the right mouse button to get another zoom value for the fader. We had the bump zoom, where you would simulate a bump over the fader, so you would have an area of heightened accuracy that would then, once you release the button, follow the fader. And yeah, basically this was all done for a big user test, which, yeah, with the results that we presented at the AES conference last week.